Dry gas seals are non-contacting, dry-running mechanical seals for centrifugal compressors and turbomachinery, utilizing engineered, laser-etched grooves to create a pressurized gas film between rotating and stationary faces. They prevent process gas leakage, enhance reliability, and reduce maintenance compared to traditional oil-lubricated seals. API 692 Part 3 defines the requirements for seal gas systems. Seal gas systems are key items for the safe operation of dry gas seals and contribute significantly to the overall compressor reliability. For this reason, API 692 committee members aim to rule and agree on the implementation of industry best practices in dry gas seal system design. The members of seal manufacturers, OEM specialists, and end users codified them into a comprehensive standard widely available throughout the industry. Dry gas seal systems do two main jobs: provide a clean and conditioned environment for the dry gas seals and monitor the health of the dry gas seal. To accomplish these goals, the dry gas seal system is usually broken down into separate independent modules that regulate and monitor 5 streams for tandem seals and 4 streams for double seals. Seal gas flows across the primary seal, inboard stage, of the dry gas seal out towards the primary vent, and across the inboard process labyrinth, back into the process. Seal gas prevents dirty, unfiltered process gas from entering the dry gas seal. This gas must be cleaned and conditioned so as to be completely dry and free of particulate contamination. The conditioning is usually accomplished via the addition of filters and a gas conditioning unit, such as separators, boosters, and heaters. This gas flows across the secondary seal, outboard stage, of a tandem dry gas seal and out the secondary vent, as well as across the intermediate labyrinth and out the primary vent. It is usually nitrogen and must also be cleaned and filtered to ensure the gas is dry and free from particulate matter. Not every seal will feature an intermediate labyrinth or secondary seal gas, but API 692 specifies them as standard. Secondary seal gas offers numerous benefits, including vastly improving the ability to monitor the health of the secondary seal. This gas is injected between the 2 separation seal elements, providing a barrier between the atmospheric bearing housing and the dry gas seal. If a labyrinth, it is injected between the 2 sections of teeth. If a carbon ring type seal, then between a pair of carbon rings. Typically, separation seal gas is an inert gas, like nitrogen, but air may also be used. If using air, particular care must be taken to avoid creating explosive mixtures in the secondary vent. These can be pressure or flow controlled dependent on customer preference. The primary vent consists of the leakage from the primary seal plus any secondary seal gas flow if present. Typically, most monitoring of the seal is performed via the primary vent. The primary vent will usually feature flow meters and pressure transmitters that monitor seal health via the leakage. Leakage tends to be a major indicator of seal health, and most alarm settings are based on a multiple of leakage. The secondary vent is the most safety-critical stream. The secondary vent flow is made up of the leakage from the secondary outboard seal and the leakage from the inboard section of the separation seal. Secondary vents should be unrestricted, meaning that nothing that can create a back pressure should be fitted. Differential pressures across secondary gas seals are generally small, and any back pressure generated in the secondary vent could easily reverse pressurize the secondary seal. API 692 makes provision for, but does not require, pressure monitoring and flow monitoring in the secondary vent. Pressure in the secondary vent should be at approximately atmospheric, and the flow rates through it should also be incredibly low.